So this activity, we're going to generate an infinite geometric series and see what the sum is. So you're going to have to do this on your own, but I'll start you off here. So we're first starting off with a 12 by 12 square here. So that's our square that we have. It's a 12 by 12 square. And we're going to shade half the area white and leave the other area we're going to shade half the area and leave the other half. So I'm just going to shade this area here and say that that's what we have. Okay, so I'm gonna let my Tn. Okay, so my Tn we'll say is 1/2, and the Sn is going to be 1/2 here. And then we'll do it again. So we're gonna use an infinite geometric series, and we're gonna just shade whatever's left over here. We're just gonna shade half here, and so that ends up being 1/4. And so our Sn, when we add up the two Tn terms, we end up with 3/4. And we're going to continue this, and we're going to do 10 terms, and you're going to add up all these terms. Okay, so what's going to happen? And we can kind of see geometrically as we keep shading. So half of that last one we shade. This one is half of that one, this is half of that one, this is half of that, and we're just going to keep shading and shading and shading. And I want you to recognize that there's no way we can shade outside the box, because we're constrained by that box. And we should see that as Tn, the value of Tn as n gets large, this Tn value becomes really, really small. This is going to be like 1 over, 1,000 and something. So it's really, really small. So we're just going to, maybe we'll just answer that right now. We're going to say the limit as n goes to infinity, as it gets really large, Tn is approaching 0. It's getting really, really small. And if that's the case, if we keep on adding zeros, eventually adding 0, there is a possibility that n has a limit. And I want you to check that out. Okay, what's happening to the value Sn as n gets large? Does it just keep on going forever? Or does it converge? And again, I'm using some new language here. Does it converge to a finite sum? And that's what you're going to be checking for in this activity. Okay, and then you want to answer these questions. You want to answer, what's the maximum total area that can be shaded? Well, the maximum total area is going to be 144 centimeters squared. Okay, so we're doing this one here. Actually, we should actually use the actual areas here. So this was 72. This was 36, so it's 108 centimeters squared. So this is going to be 18. So this is going to be 126 centimeters squared. And we're just going to keep on adding half the amount. Okay, and there is no possibility that we can get past 144 centimeters squared, because we cannot shade outside the square. Okay, so we cannot shade outside the original square. So then you're going to do two different graphs. You're going to graph Tn on the y versus n on the x. And then you're going to do a separate graph of Sn along the y and n along the x. And we want to see what's happening here. So what's happening to Tn is probably going to go down. And what's happening to Sn? Sn can't get above 144 centimeters squared. Okay, it's impossible. But what's happening? How close can we get to it? So we want to see how it progresses. Okay, and then I want you to relate how the Tn, the fact that Tn is probably going to go down to 0. Okay, so it's probably going to have some kind of progression like that. How does that then reflect on the Sn? So that's going to be the answer to this. There are some applets that you can use to run this simulation, so you can actually do shading, and you can actually choose different starting values and common ratios to see what actually happens.